Good evening, guys. Am I audible? Is my screen visible? Dear participants, good evening. Yes? Thanks for the confirmation. So I hope we can start with today's class. So in the previous classes, we are seeing about the machine learning project. Okay, before that we have seen what are the various tools and processing or the machine learning workflow with the help of scikit-learn. And then we have seen about the algorithms, and then moving into supervised machine learning, where we have completed classification project in day before class. Okay, and in yesterday's class we have completed a regression project. So with that, the examples for supervised machine learning is over. The next thing will be unsupervised machine learning. So we are going to see one algorithm and a project based on it, and we are going to discuss another thing also, which is nothing but feature extraction. Okay, so we haven't seen about that, so we'll see that also and apply this in today's class. Okay, are you guys looking forward to do with today's class? So this is day 14 of data science Naan Mudhalvan Virtual Internship, and I welcome you all on behalf of pantechelearning. Can we start, guys? Can I get thumbs up in chat so that we can start with today's class? So the link for assignment 2 will be in yesterday's class. You can go and check it. Okay, yesterday's description, you can find it there, or in the live chat you can find the link. Yes, so thanks for the confirmation. I hope we can start with today's class, right? And today is day 14, so tomorrow will be day 15, right? So what will happen in day 15? So every 5 days we are giving one assignment. So till now we have completed 2 assignments, right? In day 5 and day 10. So tomorrow's class I will be giving you the 3rd assignment, and the assignment to updated link is shared in yesterday's class. If you haven't updated it, post it and then update it, okay? So still many are doing, please do as soon as possible. So tomorrow I will be giving you another assignment, so most probably it will be a project. So I will give you a project idea with which you have to do a machine learning project, okay? So I'll give the data set and I'll explain about sections. Okay, guys? So in today's class we are going to see about one principle, which is nothing but principal component analysis, or this unsupervised learning. So this is like the feature extraction, which is nothing but the feature selection we are doing, right? In previous classes we have seen about some tests, which is ANOVA test, okay? So select k-best T2 test, so you have passed it, right? So similar to that, this PCA is kind of thing which we do, so I'll explain you about it. So I hope the assignment to update link is in chat, so those who want it, okay, please update the link. And then starting with principal component analysis. So it is a dimensionality reduction method, okay? What is dimensionality? Dimensionality is nothing but the columns or the features we are having, guys, okay? So in previous classes we have seen about feature selection, okay? This is known as feature extraction. I'll tell you what is the difference. So this is a dimensionality reduction method that is often used to reduce the dimensionality of a large data set by transforming a large set of variables into a smaller one that still contain most of the information in the large data set. So this is also called as feature extraction. So what is the difference between feature selection and feature extraction? Tell me, guys, in chat, what is the feature selection? What we will do there? So we are having many columns and we'll try to find a relationship and try to take which all columns are important for the output. That's what we'll do in feature selection. So if I'm having 20 rows, so I'm going to select the important 8 rows or 7 rows. I'll set the number using k-best, I'll perform some formula, I'll get it. That's what the feature selection is. But here, this is something known as feature extraction. So what is this difference? Feature selection versus feature extraction. So feature selection involves selecting a subset of the original feature, which means you are actually taking some of the important columns and you are neglecting some columns, okay, some features, for example. So which we have done in previous examples, right? In yesterday's class and day before yesterday's project. Extraction, this involves creating a new feature. Okay, this is going to create a new feature from the original feature in the data set which are used for model training. So this is going to create a new feature based on the features you are already having. So it helps to capture the underlying patterns in the data which is not visible for you, which is not observable. But what it will do is, if you are having 20 columns, if you pass it to this PCA or feature extraction, it is going to take some of the features from that. Okay, so this minimizes the loss of features. For example, in feature selection you are actually neglecting some columns, but when you go for feature extraction, it is going to take what are the important thing necessary, okay, from that columns. So it is not actually losing any information, it is picking the important information from all the features. That's what this feature extraction is doing. Is it clear, guys, what is the difference between feature selection and feature extraction? Can I get thumbs up in chat box? Did you understand the concept behind this feature extraction? This takes some of the columns, this transforms all the columns and create a new feature, okay, based on the number you require. You can give it actually. So that we will see in the next slides. Is it clear, guys, regarding feature extraction? Quick, I'm waiting for your response, guys. Okay, so how this PCA works actually. Okay, so you are going to pass a high dimension data, which means you are, for example, you are passing 10 columns. So this is the high dimensional data. Okay, so it is trying to fit the center of the points. Okay, then compute the covariance matrix. This is the mathematics or statistics behind this. So it is going to plot the eigenvectors and eigenvalues. Okay, so it will pick the eigenvectors with highest eigenvalues. Based on it, it will try to plot. So it will project the data points to those eigenvectors, and finally it will try to, like, dimensionality, it is going to reduce it, okay, by combining all these features. So if I tell it in simple terms, it will take all the features into account and take the important features and turning them into a two-dimensional one. Okay, so this is how you can perform PCA with sklearn. From sklearn.decomposition, import PCA. Okay, so you have to create an object for it, and then PCA equal to, okay, I'm passing the n underscore component. So that's what will select the number of features you want. For example, if I'm passing many columns, I want to combine them and get it as a 2 features, I can pass the n underscore components as 2. So I can fit and transform the data, we'll do it. So when we complete this, we'll go into the machine learning clustering project. Can we do it, guys? Can I get thumbs up, guys? Are you guys there listening? Is it clear till now? So I have an example for you guys. So this is a breast cancer dataset, okay, healthcare dataset. Okay, I loaded the dataset, and so I'll load it in this also. If it is required another time, so I'll go. Okay, before that, clear, guys? Am I audible? Is there any internet issue? I hope no. So what we are going to do, so before going into PCA, you have to actually scale the values, okay? So you have to, I'm just encoding it, this will be the output, okay? The diagnosis, I'm just encoding it, and I'll go with data.head. And in that I'm selecting these columns, this ID and diagnosis I don't want in X, I want these columns alone, features, okay? So I'm selecting all the features, the required features in X, and the Y it is there, a diagnosis I'm just turned into fit transform. I have encoded it and it is in this variable dataset. Okay, that's why I have created 2. So this dataset will have the diagnosis column, it is encoded. Okay, and in data, see here, this is encoder. Now I can take it as a y value, and in x I am selecting from 2, which means from this column I am taking the entire thing, because these are all the features I require. Okay, so I'll tell you how much column they are present. Data.columns. Okay, so I can go and print the length of this, right? So there are 30 columns. So first I'll fit and transform with standard scalar. Okay, so if I run this is going to transform it. Okay, I'm just turning them into data frame again. So now it is scaled value. With what will standard scalar do? It will convert them with the mean value of 0 and standard deviation of 1, right? And from sklearn.decomposition I am importing PCA. Okay, I am creating an object for it, PCA n underscore components equal to 2. So I am fitting and transforming. So this is my new value will look like. Okay, it transformed this 30 columns and take the important features and turn them into 2 columns. Okay, so I just plot these values. So this can be passed to the machine learning model for further predictions. Okay, so it turned that 30 columns into 2-dimensional, like 2 features. Okay, first principal component and second principal component. Clear? So this is what the PCA is doing. So next thing, we are going to start with the machine learning clustering project, so where I will be using PCA also. So at that time I will show you what the output will be. Okay, so going with this machine learning clustering project. So mall customer segmentation using machine learning. So this is what we are going to see. So this is a customer data set from a mall. Okay, so what is unsupervised machine learning, guys? If your data set don't have any like output where you are going to predict any labeled output, that will comes under labeled or supervised learning. But here there is no labeled output, which means it is unsupervised learning. There is unlabeled data. So we are having some of the details. You don't have any output to map. Okay, so we will do what we are going to do in unsupervised machine learning is we'll try to find the clusters. So what is this cluster is? We are going to group the people into separate categories. Okay, for example, if you are having 1,000 customers of a mall, you are trying to split them based on their how much they are spending and what is their salary. So based on it, you are trying to group them. For example, if you are trying to group them into 10 category, okay, so if you are having a new customer, what you can do is based on the category he is fitting, you can offer them separate like coupons, or you can do certain advertisement based on it. Okay, based on specific group of people, if they are alike, okay, you can cluster them. So that's what the idea behind this small customer segmentation using machine learning. So this is unsupervised machine learning. We are going to segment, like cluster them. So in the field of marketing, clustering can be used to identify various customer groups with existing customer data. So based on that, the customer can be provided with discounts or offers, promo codes, etc. So mall data is an interesting data, okay, where you can try this. With unsupervised machine learning technique, we are going to make the customer segmentation by using clustering algorithm. So that we are going to see about k-means clustering. Okay. So what is actually clustering? See here, if I plot my data and I can find, see here, these are like a group of people. So I am clustering them. And these are another group. You can see it, right? With your eyes, you can see it. So I can separate them into 3 groups. So based on it, I can offer them different approach. So if a new customer comes, I can fit him in anywhere of this place. If he belongs to this green, so I can accommodate in that and offer him separate promotions. So clustering is a type of unsupervised machine learning in which the algorithm processes our data and divide them into clusters. So the algorithm we are going to use is k-means clustering. So k-means algorithm that can divide the given data into given number of clusters. So if you give the cluster number, for example, if I want to, like you have to give the number. If I want to cluster them into 3, so it is going to cluster them based on that and turn them into 3 groups. If I give 6, it is going to find the 6, okay, 6 groups in this. So how it is doing, we'll see that later. So this k-means algorithm, whatever the number k value you will be giving, the number you are giving, that much it will group them. So k number of the clustering that we need to be created. So it is a centroid based algorithm. So they are telling it is a centroid based algorithm in which the cluster associated with the centroid, the main idea is to reduce the distance between the data point and the respective center clusteroid. So if you are having a group of data, you can cluster them and separate them. So how this? what they are telling, what is this centroid, okay, how this is working. For example, as I told you earlier, the k number I should mention. Okay, if I mention into 3, it is going to split them into 3. If I mention as 4, it will try to find 4 groups. How it is doing? Okay, so it will try to fit a centroid. So what is a centroid? A center value. For example, where the data is grouped, it is going to plot. If I mention the k as 3, here there will be a centroid. Here there will be a centroid. Here there will be a centroid. Once it places the centroid, this point, okay, this point is nearer to which centroid? This centroid or this centroid or this centroid? Okay, so this one is related or near to this one, so it belongs to this group, this category. So here, if I have this point which is nearer to this centroid or this centroid, this one is near, so it is going to belong to this group. So based on the centroid, this is actually creating the group. Is it clear, guys, till now regarding k-means clustering, the idea behind it, or the centroid? Is it clear? Can I get some response from you guys? Yes, okay. So we'll continue with that. Now the question comes for you guys. Tell me, guys. You are mentioning the k value to split them. Okay? You are going to mention the k value. Based on it, the algorithm is going to try to fit the centroid and cluster them. Now comes the question. What will be the optimal or best k value? How are you going to find it? How will you find the best k value? You have to do something, right? There should be some way to find the best k value. And there comes something known as k clustering calculation. There is actually a calculation for you guys. Like, you are not actually going to do this. We are going to perform it with Python. So with this, we can get a value, or we are going to do something. With that, you can find the optimal or best number for the k value. Fine? Is it good, right? Right, guys? No, it's not mean value, so I'll tell you how to find it. So to do this, we are going to use a formula which is nothing but WCSS, which is known as within cluster sum of squares. So against it is the number of clusters, k value, okay. So we are going to use these both of this to figure out the optimal number of clusters. So we are going to calculate something known as WCSS. So this can be done with the help of algorithm itself, okay. So with that, we are going to plot with the k value and find it. So here comes a new method, which is nothing but elbow method, okay. We are going to use something known as elbow method. As I told you earlier, listen guys, we are going to calculate this WCSS, right? So this WCSS, you can calculate with the help of k value. So I am going to calculate the k value. If the k value is 1, what is the WCSS value? Okay. If the k value is 2, what is the WCSS value? Obviously the k value can be from 1 to 10, okay. So if the k value is 3, okay, what is the WCSS value? So I am going to calculate using a for loop. Okay, from 1 to 10, I am going to calculate the k value, WCSS value. So I am going to plot the WCSS value as y and the number of clusters as x. So at first, okay, 1, 2.5 it is. Then 2, what is the value? Here it is, 3. So I am going to plot it. So once you plot this, you have to find the elbow point. What is the elbow point? A sharp turn like an elbow. You can actually see the turn. Okay, here, this is the elbow point, 3. Where you can see a trend, a change, okay. So compute k-means clustering from 1 to 10, calculate the WCSS for each, plot them against WCSS versus the k value. The location of a bend knee in the plot is generally considered as an indicator of the appropriate number of clusters. So this, where you can find the bend, is the appropriate or best k value. Clear guys, how this elbow method is done? Is it clear? And if you want the math behind this k value WCSS, okay. So for example, at first you are setting the k value as 1. What does mean by k value as 1? Tell me guys. It means only one cluster. So it is going to combine all of these things into one cluster. So there should be a centroid. Okay, that centroid, for example, if it is here in the center point, okay, what is this WCSS? Within cluster sum of squares. So what this calculation is actually, okay, it is going to calculate the distance between all the points with the centroid. So if the k value is 1, okay, this distance between the points will be actually high. Why? Because these points, all the points will comes to this centroid. So that's why every time you plot it, the k value is 1, the point value is going to be high. So then when you keep on going, okay, if you have optimal number of clusters, so it is going to calculate based on it. Yes, elbow method is used to determine the best k value in k-means clustering. Wherever you go, you can see this only. We are going to calculate the WCSS value and then plot them for 1 to 10. Where the elbow is, that point is the actual k value. So here the k value best is 3. And we'll try the project where we can find what is the actual k value. We'll try to get it there. Okay. So starting with the project, guys, now. So the clustering project for today's class, I'll refresh with the, I got the data set. So I'll run this. Okay. So I'm loading it. So I'll go and get the head for you guys. So this is our customer data set, guys. What all we are having? See here, we are having customer ID. So obviously customer ID is not going to do anything. I'll be replacing or drop them. And we are having gender. It is just the name is wrong, so we have to replace or rename the name. And we are having the age of the customer, their annual income, what it is, okay, in thousands of dollars, okay, k dollar, and the spending score actually 1 to 100. Spending score is something like mall or this mall is, right? They are giving some value based on how much they are spending. So this is from the value 1 to 100. Okay. So I'm just going to rename the columns this one as gender. Okay, since it is not given correctly. In place equal to true. This is common. You can find this data set if you type mall customer data set. You are going to get it from Kaggle. You can search it or get it from Kaggle. Okay, so next I'm going to drop this customer ID because it don't have anything to do with. And can you see another thing, guys? I told you, right, this is unsupervised learning because there is nothing for you to predict. You are just going to find the cluster or group these customers, so that if you got a new customer, you are going to place them in any of the group. For example, if you are having 3 groups, okay, you can give them different discount based on their group. And I hope have I dropped this customer ID. Okay, now it is these columns alone, these can be the features, right? So I'll go and get the shape of it. So it seems like we are having 200, okay, 200 rows and 4 columns, 4 important columns. So we are going to analyze. So here in this project there will be only little kind of EDA, okay. So we are going to focus on the WCSS and the elbow methods. So I'll go and get the info, isNull.sum. These are the features. It seems like there is no null value. Good. Then I'll go and get the describe, okay, and we are going to get the correlation now. And from this correlation, what you can understand, guys, the age, okay, age column is having a negative correlation with the annual income, okay. So the customer they are having, if they are in high age, okay, their annual income is less in this data set, and their spending score is also less. Obviously, if their annual income is less, their spending score is also going to be less here, okay. So the young customers are having, it seems like this is mentioning negative correlation, which means the young customers are having high annual income and high spending score, okay. Clear, guys? Okay, older customers have less income, therefore they spend less money. And next I am going to plot the spending score, dist plot, age dist plot, and annual income dist plot in a single image. Okay, this is going to be a subplot. Wait a minute, guys, it's less rolling. Okay. And what you can see, the spending score is actually a normal distributed data, Gaussian data, and the age is slightly, okay, it's not that much, but it is slightly skewed, and the annual income also. So this spending score is actually a best Gaussian data. You can find it, right, a bell-shaped curve. The distribution is normal. Okay, now I'm going to get the gender column. We are having male and female, right? So it is a text value. I'm going to encode them. See here, male, female. So I'm going to get the value underscore counts. So it seems like the female are 112 and the male are 88. Okay. So label encoder, I'm passing it. So once I done it, encode it. So the female are returned as 0 and the male are given 1. Okay, in this data. You can compare, right? Both of this. I'll go and get the head now. Okay, now everything is in the numerical format. So we are going to go into the exploratory data analysis. And I'm going to calculate the spending score of male and female. So wherever it is male, okay, I'm just calculating the spending score and adding with this. Okay, wherever it is female, I'm adding with that. Okay, totally we'll see how much the spending score totally. So the male spending score is this value and the female spending score is this value. So next I'm going to plot a bar plot, okay, based on the gender. Okay, so what you can understand from this, guys. So you are plotting the numbers first. How many female and how many male? 112 females and 88 males. Okay. Next, we are passing gender versus total spending score and gender versus mean spending score. Okay. I am plotting the total spending score and mean spending score. And what you can see, guys. So it seems like there is no significant difference in the mean spending score, which means both male and female are having equal spending score. Okay. Since the mean spending score are very close to each other, difference between the total spending score is the difference between the number of male and female customers. But this is not a serious difference. Therefore, in this data, the gender is not actually a deciding factor because they are having like equal importance here. Okay. So in this customer data set, this small, the male and female, their gender is not actually an important factor. So with that left, okay, what will be the remaining things we are having? Spending score, age, okay. So I'm going to plot with age and spending score. What can you see from this, guys? What it is telling? Can you find it? Can you find between this 20 to 40? You can see many groups here. Okay, so the age people from 20 to 40 have made more purchases. Okay, so we'll go and look into the relationship between the annual income and spending score. Okay, this is what the relationship between the annual income and spending score. So you can find two regions. One will be between 40 to 60. Okay, you can find a group. Okay, the number of audience is high, but the spending score is actually low. Okay, here there are many groups, but it is not that much high. Okay. So if we make shopping attractive for them by choosing the target audience between these two regions, okay, we can see more profit. So next, we are going to go with choosing the optimum number of clusters. Actually, we are going to take and do the WCSS, guys. I'll tell you how we are doing, okay. So in X, what I am doing, I am locating, okay, all the rows and selecting the column 2 and 3. What is 2 and 3 here, guys? df.head. What I have done, I am selecting the important features. Okay, I am going to group them based on the annual income and spending score. Okay, I am not going to consider gender and age. Okay, and I am going to take the annual income and spending score as the important two features to cluster them. Okay, so I am taking the index 2 and 3. This will be 0, 1, this is 2, this is 3. So I am taking in X. So you can actually go and see the X dot head. And now we are going to calculate the WCSS value, guys. Okay, X is, okay, this is what we are having X. So it's not a data frame. That's why it is not giving me the dot head. I can convert them into data frame or leave it as such. So first create a list, guys. Why we are creating a list? Every time the loop runs, okay, for the k value 1, I am going to store the value. K value 2, I am going to store the value. That's why I am creating an empty list. So this k-means algorithm, you can import it from sklearn.cluster import k-means. I am creating a loop for I in range 1, 11. It starts from 1 and if I mention 11 here, it is going to end till 10. So which means the k value I can pass with this I, which is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So how to do this k means, how to calculate the WCSS value? I am going to create an object and k means n underscore clusters. This is actually the k value, okay, or the number of clusters, okay. So I am passing the I here. So every time the loop runs, the I value is going to go from 1 to 10. And the method I am going to use is k means plus plus, and the random set I am setting to 42. First I will fit the value, okay guys, I am not going to predict it, I am just going to fit the value. Once I fit this, okay, I can get something like dot inertia underscore. This dot inertia underscore in this object is nothing but the WCSS value. Okay, this value I am just going to append it with WCSS. So I can actually print the WCSS every time the loop runs. Okay, so if I run this from 1 to 10, okay, it's giving me the warnings, but see here, this is the first loop, this is the second one, the value got inside, so it is keep on running, and finally for 10 values we will be having WCSS. Okay, the values, all the 10 values are here. You can print the length of it. Okay, how it is done? Every time the k value gets added with 1 or changed with 1, okay, passing the k value here, the WCSS value can be get from this object dot inertia underscore where you have fitted your data. Okay, then it is appended with this list WCSS. Now I have the WCSS value for 10. Okay, how to get an elbow graph? It is a plot between, what is the y-axis? Y-axis is WCSS value and the x-axis is from 1 to 10 the k value. So if I plot this, and here comes the elbow point graph. Now we want to find what is the optimal number of clusters or k value or n underscore clusters. What can be the best k value, guys, from here? Tell me, guys. Where can you find the elbow point? And here it is little bit tricky. We are having something like 2 points. What are the values you can see? Elbow. Tell me, guys. Tell me, guys, what are the 2 points? Yes, correct, 3 and 5. Where 3 is, here we got 3. Here we got 5. Okay. But when you see a sharp elbow turn, you can see it from here, 5. Okay. So I am going to select the optimal number of clusters is 5. So sorry, it's not 2.5 or 4.5. So the middle value will be 3. It is like 2 step, 2, 4, 6. The center value is 3. Yes, 3 and 5. So I am going to select 5 because it is the optimal number here in this graph. Okay. So I can set the same thing we have to do, guys. Here we have fitted or trained the model. Okay, the k means we have trained it and got the WCSS value from that. Now we got the optimal number, which is 5. So I can repeat the same and fit the data with n underscore cluster equal to 5. Okay, once I fit and predict, I am going to do the same and get the x value. Okay, I am store it in y because there is no output y. Okay, guys. So if I run this is my y value. From this, what you can understand? Tell me, guys. What is this y, guys? As I told you earlier, we are going to split them into 5 groups. Okay, we are trying to split them into 5 groups. It is actually splitted them into 5 groups. 0, 1, 2, 3, 4. Okay, totally 5 groups. 0, 1, 2, 3 and 4. So if this is 4, which means the first value or the first person belongs to the 4th group, and the next person belongs to the 3rd group, and the next person belongs to the 4th group, and so on. Okay, clear, guys? You can actually go and get I'll create a dummy data set where I'll create this as pd dot data frame. I'll pass this y. Dummy dot head. Okay, I can go and get dummy in that 0, right? Dot value underscore counts. Okay, so it seems like in the first group 81 people are there, in the second group 39 people are there, in the 0th group 35 people are there, In the fourth group 23 people are there, and in the third group 22 people are there. Okay, this is how it is clustered, and I'm going to plot these clusters. Okay, and I'm going to plot the centroids also from that values. Okay, you can get from that object, you can get this cluster underscore centers. So this is going to give you the centroid value. Okay, if I run this, I'm going to get a plot based on the centroid cluster. Okay, so it seems like we are having 5 groups. Okay, and this is their centroid. So based on it, these points are fitted. This centroid, these points belongs to this centroid, these points belong to this centroid. Okay, so it has split it into 5 groups. If you pass 3, it is going to split them into 3 groups. Okay, now we are going to perform PCA. Okay, because in that 4 column we are actually took 2 column alone. Okay, 2 features, and we have done this. But okay, whether it is important or not, I can go and use this PCA to extract the values from all those 4 and take the important one based on the eigenvalues. So what I'm going to do, I'm going to fit and transform and first scale them. Okay, I'm scaling them first. Okay, once I scale it, I'm going to use this one. Okay, so before that, in X, okay, instead I'll pass the, wait a minute guys. So I'm scaling them, and then what I'm doing, I'm importing the PCA and the components. I'm setting this to 2 and transforming them. Now we got the transformed feature in X underscore 2D. Okay, so this, now I'm going to create the WCSS again and try to find it. Okay, from 1 to 11 I'm plotting it. So this is what the elbow method, I got it now. Now tell me guys, which is the optimal point from this? Instead of passing the spending score and the their annual income, now we took all the 4, which is nothing but the age, the gender, the spending score, and the annual income. From this 4, I used PCA to extract the features and turn them into 2 data, and that we are using for calculating the WCSS. Now tell me the optimal number of clusters from this elbow point. Now the optimal number is 4, right? Yes, 4. So what I'm going to do, I'm going to set that as 4, and I'll predict and visualize the groups. Okay, so once I visualize it, it is going to give me, so these are the 4 groups. Okay guys, so you can get the legend with color if you mention it. Okay, this one belongs to this group. So how it is calculating, if there is a point, it is going to calculate the distance between this one and this one, which is near, it belongs to that cluster. Okay, clear guys? So this is a basic clustering project. This is a common project, you can see. So we are not going into the advanced level, since it is the first unsupervised learning we are seeing. Okay, with this, okay, they can create a predictive system, and if they got a new customer, they can actually try to find which groups he belongs to. If he belongs to this red group, okay, so what all these features, okay, what is their taste, what you can do to attract that customers, you can do it. So that's what this small data set is doing. Okay, small customer segmentation data. Clear? The attendance link will be circulated soon, so please wait. And in tomorrow's class, as I told you earlier, we are going to see a project by using algorithm which is pre-trained. Okay, so there are some algorithms which is pre-trained on some tasks. You can actually select and import and use it. Okay, so it is already trained on some kind of data, and it is somewhat good. So what you are going to do is you will be training on your data and try to accommodate with that, and with that you try to get the output. Okay, there are some algorithms like it. We'll see about that in tomorrow's class. Okay, tomorrow will be day 15. So in day 15, I'll be giving you another assignment, which will be a machine learning project, which you have to do and try to get the answers and output. Okay, so please make sure you are attending tomorrow's session also. And after that, from day 16 to day 20, it is very important and crucial guys, because we are going to see about deep learning and NLP, natural language processing. Okay. So with natural language processing and deep learning, we can go. In machine learning, we are using algorithms. Okay. In deep learning, we are going to use neural networks, which are created to simulate, like to act like a human brain. Okay. When we are starting machine learning, I have told you about the introduction of deep learning, right? How neural networks are created and used. So we are going to see about it. So with these projects, we can go some more advanced, okay, by applying their instead of algorithms. Along with algorithms, we can pass the neural networks and try to get their accuracy also. Okay. PCA part, yeah. Okay, listen. So if you are going to use PCA, you have to standardize the data. It is mandatory. Okay, standardize using standard scaler, because you have to have a mean value of 0 and standard deviation of 1. Okay, then only PCA can work well. Okay, you are going to scale it. Once you are like, this can be done in classification project or regression project or any data. Okay, not for this one alone. Okay, and this, okay, once I scale the data, I have to select the PCA number I want. For example, if I want to turn them into 3, okay, I can do this. See here, I got 3. It is going to take the important features. As I told you earlier, from the eigenvalue, which is high, it is going to take it and transform them into a 2D. If I pass 3, it is going to turn them into 3, okay, from the 4. What is the advantage of this? When you compare with the feature selection, okay, you are going to select the important columns, but you will left some column. For example, here we have done it manually by visualizing the data. And we have seen some of the methods like mutual information classifier or regressor, ANOVA test, G2 test, and then what we have seen, the correlation test, okay, and all these things we have done, right? So where actually we will be selecting only if I want 2 columns, I can select these 2 and I will be neglecting these 2. So this won't play any role, but it may play, okay, even though it is not that much important. In some places it may play a huge role. So that's why instead of neglecting these things, we are going to pass this to the PCA, where it will take all these, it will consider all these and take the important values from each of the one. Okay. So that's why this feature extraction is very important. And from feature extraction, we can understand this can be classified into 4 groups. That will be best. You can just fit and transform it, guys. This is just simple. You can import it from sklearn.decomposition, import PCA, okay, and you have to create an object for it, where you have to mention the n underscore components. So this will mention how much component you want from that, however you are going to transform it into 2 I want. So I'm just fitting and transforming the data, and then I'm doing the same process. Okay, is it clear? So in tomorrow's class, we'll try to see another machine learning project where we are going to use a pre-trained model. So there are some, we'll try to explore that. Okay, so that will give you some more idea. And then later on, we are going to see about deep learning and NLP and their projects. Okay, we are going to see one project for each. Okay, so that will help you to understand more. And tomorrow I'll be giving you a project for you to do. So please try to whatever may be the accuracy, guys. Try to do one project on your own, then you can improve. Okay, on practice you can try and do different things and improve it. Okay, so if you haven't updated the assignment, please make sure you are submitting and updating it as soon as possible. Okay, so that's it, guys. Thank you. Thanks for watching. I hope in the past 3 days we are seeing the projects. I hope it will be clear for you how we are using machine learning as a tool to get valuable information for the data science.